Erik, shall we start?
Yes, I think we can.
Okay, so good evening, everybody. My name is Elmar Kotter from Freiburg in Germany, and I am happy to welcome everybody to this EuSoMII webinar on cloud imaging or cloud technologies in radiology. Erik Ranschaert will talk to us this evening for about 30 to 40 minutes. For those of you who don't know Erik, I think most of you know him, but for those who don't, he's a Belgian radiologist, worked for quite a few years in the Netherlands, and now is back to Belgium, where he's head of the Department of Radiology in Mol in Belgium at the Hartzikenhuis. Erik has been he's a gastrointestinal radiologist and oncologic radiologist, but before all, he has been one of the very early people going digital in radiology, and that's what he's really known for within the European and even American community. He has driven many projects very early, like the EuFora project in the 90s, already European Forum for Radiologists, and since he has always continued to really be at the forefront of digital technologies in radiology. That's why we are very proud to welcome him today and to get news about cloud technologies in radiology. Erik, one more thing, we will have discussion after the talk of Erik. If you have questions, please type them in, and I will try to resume at the end of the session and to read the questions and ask Erik to answer them. So let's welcome Erik. Please, Erik, go ahead.
Okay, thank you, Elmar. Thank you very much for this kind introduction. And indeed, yes, I would suggest that the attendees can just type the questions, and then we will discuss a selection of them at the end of the webinar. So tonight I'm going to talk to you about cloud technologies in radiology. I do know that a lot of my colleagues are still not very well informed about what cloud technology means. What is it all about? Is it in a cloud somewhere, or what exactly can we do with it? So this is what I will try to explain to you tonight with this webinar. So as you all know, we are living in an era of online information sharing. We have become accustomed to this type of service. Not only private persons, but also enterprises. They are moving many types of information via the internet. And then I'm talking about, especially for private people, about music, pictures, about videos, but also, for example, about financial information and banking. And so the society finds this type of information exchange quite efficient and desirable. The acceptance of this type of exchange of information indicates a reasonable level of trust. So this means that we are confident in using it. Also for healthcare services, there is a tremendous level of progress in cloud technology. This progress is already present, but maybe not always used or very widely used yet. So in healthcare, there's a special challenge to this kind of online information sharing. And the challenge is that it should be ensured that the highest level of security and confidentiality is possible for sharing healthcare data. So this is one of the main issues. What is the definition of cloud computing? Well, this is kind of a broad definition. It's kind of a model to enable convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with a minimal management effort. And these computing resources, those can be networks, for example, or servers, or storage capacity, or software applications, and all kinds of services. So they are, if these services are rapidly provisioned and released with a minimal effort, then we talk about cloud computing. So the cloud is here graphically displayed. It's an element, it's a collection.
Erik?
Yes?
Erik, 1 second. We only see your first slide for some reason.
Okay, that's bizarre. So I will try to show you the other slides as well, maybe.
Somehow you're not in presentation mode of your PowerPoint.
And how about now?
We still see the preview on the left side, and now we see what's cloud computing in the center, but not in the presentation mode.
Okay, this is kind of strange. I will see what I can do here. Screen share. Let's see, screen share.
Do you have it in presentation mode?
Now you see the browser of the PowerPoint.
Yes.
Okay. Okay. Let's see what I can do then. And how about now? You don't see the graphics of the cloud system?
We see, but only top part.
What is the cloud?
What is the cloud? Yes, and the last sentence we see is no end user knowledge of, and then it stops.
So you only see part of the screen?
No, we don't see the presentation mode.
Oh, okay. Now I see what you mean. Well, and now you see the whole slide?
We see the whole slide, yes.
Okay, then we will have to work this way, I guess.
Okay, much better.
Much better? Like this? Okay.
Yeah.
So yes, the graphics will not work then, unfortunately, but okay. So the cloud is a combination of computation, it's software, it's data access, and it's storage devices. The main thing about it is that there's no end user knowledge of the physical location and the configuration of the system delivering these services. So we don't know exactly where is the installation. The cloud actually exists. Well, there's this is a kind of a mnemonic. That's number 3, 4, 5. So what I want to explain you with this is that there are 3 types of service models, 4 deployment models, and 5 characteristics describing the cloud. The 5 characteristics you can see in the left table. The first one is on-demand self-service, so you can use it as you want. The second one is ubiquitous network access, access from everywhere. The third characteristic is the location-independent resource pooling. There's no, it doesn't matter where the resources are located. Fourth characteristic of cloud is the rapid elasticity, so you can expand it as soon as you want. And fifth typical aspect is the measured service, so you can the services that you get are the ones you want on demand. There are 3 service models, and the first is software as a service, so which means that you can use specific applications through clouds. The second one is, I will explain this more detail in the next slides, but the second one is platform as a service, so that means that you use the cloud for a suite of applications, which can be programming languages and other using tools. And the third model is the infrastructure as a service. So then you rely on storage networks that are remotely located. I will show you this in more detail. So here you have the same. On the bottom you can see the orange squares, which are the 5 characteristics. And in the middle you can see the 3 deployment models. So you have the software as a service, the platform, and the infrastructure as a service. So the software is the basic use, and the infrastructure is the more wide use of using the cloud services. So we have 3 and 5 already, but there are 4 deployment models, and these are the following. The first one we already know from daily use. It's the public cloud. It's offered by public cloud service providers, and everybody is using it. I'm talking about services like Netflix, for example, or like Spotify, etc., Dropbox and Google Drive. Then we also have a private cloud, and the private is completely secured. It's totally under control of the owner or the one who uses it, and it's offered by private cloud service providers. It's used, for example, by a hospital, one hospital. Then we have the community cloud, which is a group of organizations or a group of hospitals, for example, that are using it as a collective network or organization. And then the fourth one is the hybrid cloud, which is a combination of public and private. So it could be part of the cloud could be public use, and another part could be only for private use, which means that the access is protected. I will give you an example later. So with this slide, I again want to explain you the three types of service models, which is the software as a platform as a service, the platform as a service, and the infrastructure. Software as a service means that applications are hosted by a cloud service provider. For example, this can be an electronic health record or patient record. And so these services are made available to the customers over the internet. When we talk about a platform as a service, we should think about development tools such as an operation system that is hosted in the cloud and accessed through a browser. Developers can use this to build web applications for the hospital without installing any tools on their computer. And such applications can be deployed without any specific or specialized administrative skills. And then the third one is the infrastructure as a service, which means that the cloud user outsources the equipment, which means the hardware, to a cloud service provider. So there's less local hardware available or necessary, which means, for example, if you want to expand your storage capacity, you can outsource it. So the provider, the cloud service provider, he owns the equipment and he is responsible for housing, running, and maintaining it, not the hospital. This is an example of a hybrid cloud. In Belgium, it's very known. It's a service called PACS on Web, and it allows hospitals to make the images and even reports available for patients online. You can log in as a patient on a web browser, or you can log in as a doctor on the web browser. So all the information of a specific patient can be accessed by using a birth date and a specific private code. The patient can also go elsewhere and show these images to somebody else. So this is a type of a hybrid cloud. What are the current issues that are going on or relative in imaging informatics? So we are confronted with an imaging overload. There's too many images, or the amount of images that we are producing is increasing. And we also are going to a shift on value instead of volume. So productivity is, or let's say the value of radiology is more being appreciated than the productivity. And we also, radiologists are focusing increasingly more on the value of the services instead of the volume of their services. Another issue is the system integration. There's an increasing number of systems available in healthcare, and they need to be integrated. So, for example, the electronic health record needs to be integrated with a PACS system. We are also discussing the form of the radiological report. How does a report has to look like? Does it have to be digital? Does it have to be a structured report? Do we have to share the report with the patients, etc.? And there's also a very important issue nowadays, that's the image sharing. How can we do this securely? Who has to get access to the images? And how do we protect patient data, for example? Another thing is the value of PACS. Do we still have to think about PACS as we have been doing the last few decades? So is PACS still for radiology? Is it only for us? or are there also other specialties that have need for both storage of static and cinematic images? So yes, there are often other specialties. As you can see on the image, we have dermatology producing images, ophthalmology, pathology, cardiology, etc. So all these images, they have to be stored somewhere, and maybe we should define PACS as a storage for multiple specialties, which also, for example, asks for a more unified management of data and images. So I think that we are progressively moving from PACS for radiology to any ology PACS. But this issue currently is not sufficiently addressed by the existing methodologies. So what we certainly need is more storage capacity if we're going for this type of PACS. And we also know that there is a continuous increase of medical imaging. We do have new techniques producing larger data volumes, and then we think about, for example, hybrid imaging, PET-CT, PET-MRI, or we think about the new MRI sequences that are increasing. And as I said before, we also have other specialties wanting to store images. On the other hand, we also need more storage capacity for allowing new cloud-based techniques that are working on image recognition. If we want to apply deep learning techniques, then we need a lot of images. These software developments do need a lot of radiological images. So if we want to store them, we also need a lot of capacity. To make progress in deep learning software and developments, we need an enormous data input and storage capacity. We need more computer power. So this will be key to development of artificial intelligence. Now I will show you the difference between the traditional image storage as we still use it in most locations, and the cloud-based version. On the left side, you see the traditional storage system, which means that, for example, in a hospital group or network, we have different sites, sites 1 to 3. Every site has its own hardware and its own applications. And this is the so-called silo architecture. So it means that it is quite intensive and expensive to manage all this equipment. And often there is not sufficient bandwidth to share between not only inside the location, but also between the other locations. This type of configuration is quite vulnerable to failure and downtime because there's a lot of hardware and software running on different locations. And the installations are different for each site. Now, when we go to a cloud-based system, there is one shared cloud-based storage platform which is shared by all these different sites. So we have some kind of a virtualized architecture, which of course is also shared and thus more cost-effective. There's also more speed, higher speed accessibility, and there's one single point of access, which could be, for example, the electronic patient record or a portal. So this way we can eliminate redundancy, not only in equipment, but also in examinations, for example. We will discuss this further. So why should we use the cloud? For several reasons. First of all, there is the patient empowerment, which is now developing strongly, and it means that patients are using the web as well. So they have mobile access to information. It's more easy for them to gather images from the hospital or to view images from the hospital on mobile devices. And for them, it's also possible to obtain second opinions this way. There's also the development of telehealth. Health services are being provided from distance. So this means there's a more broad market for healthcare services. And there's also a growing collaboration between hospitals because hospitals are becoming more specialty oriented. So when using telehealth services, they can exchange this information more easily. And we are also going to a more personalized medicine, which means that treatments are being developed depending on the specific DNA pattern of a patient, or for example, there will be more specific treatments for specific cancers that are related to a specific genetic pattern, etc. So if we want to use this information, it will be necessary to exchange it more easily. We also have, when we use the cloud, we have more easily access to information. So this also means that it will be more easy to make outside referrals of patients to outside facilities, for example, to academic hospitals. And this way we will also avoid redundancy, as I already said. So we are going to some kind of a situation where we have liquid data and where we can transfer studies in an elegant way. And this has advantages for example, trauma patients, or we're talking about patients with cerebral infarct. These patients sometimes have to be transferred to another location for treatment for embolectomy, for example, thrombectomy. So when we share this information, the preparations can be made in advance before the patient is there, or the right specialist can be contacted timely. So the hospital this way will be able to function will be able to function by sharing information more fluently, and this will organize patient care more efficiently, and the care that is provided will be more patient-centric. This is an example of how image exchange will be possible with the by using the cloud as a platform as a service. So in one location, community hospital, for example, we have the scanner, we have a PACS server, we have the radiologist, and these from this location, the images can be sent to a vendor-neutral cloud-based medical image and document exchange system, as for example, the PACS on Web system we have in Belgium. So from this cloud-based system, the images can be sent to another radiologist in another institution, or they can be even sent to the physician referring the patient. So this is one example. So the cloud computing environment here is used to transfer images to different institutions and clinicians in physically separate locations. So when we talk about cloud services for image processing, we talk about software as a service. So here we have a similar situation, a hospital with a diagnostic center with a scanner. Images are sent to the PACS, and from there they can be sent to the cloud, but the cloud is used differently here. The images are being post-processed in the cloud. And this can go several ways. For example, the cloud can provide 3D imaging software to the local radiologist that uses it in the hospital. Or the post-processing can be done elsewhere by the clinician, for example, or by a radiologist located elsewhere. So this way, different type of post-processing is possible. For example, evaluation of follow-up oncology patients can be done remotely by specific cloud-based software, and then the results are being sent back to the hospital. So the advantages of cloud are multiple. First of all, and I will explain this in more detail in the coming slides, but the cloud allows an economy of scale. We also call it cloudonomics. The cloud improves the performance, it enables enterprise-wide imaging, and it increases the quality of care. So cloudonomics, what does it mean? Well, in a classic system, which means a statically provisioned data center, we see that the capacity is often too high, the available capacity, and the need is fluctuating. So there is often a lot of unused resources, so the capacity is too high. When we use a virtual data center in the cloud, then we can just adapt the capacity depending on the demands or on the needs. So we don't have unused resources. So this is why they call this cloudonomics. It improves the performance, and in several ways. We know that there are current trends in radiology, and I already mentioned them. The data sets of images are growing. There's an increasing use of software for workflow processing. There's also an increasing pre- and post-processing requirement, for example, for oncology type of evaluations or functional imaging. And there's also an increasingly distributed environment, so we distribute information. The advantages of the cloud are that we can make the means more flexible for the IT department. So they will have to invest less in hardware, and it will be possible to expand more easily, more flexible. There will be a greater anticipation of fluctuations in the user load. So there will be less upfront investments for additional hardware and software, and if needed, there can be a rapid expansion, and there can also be, and this is possible, there is also a robust reliability of cloud-based services. So overall, we have a better performance for clinical users, and we can focus on clinical work instead of IT. Enterprise imaging, what does that mean? Well, it means that cloud-based solutions can provide a solution for the workforce problem, which means that work lists can be shared across different centers. So there's a platform for collaborative working across different sites. And there's also a possibility to get speedy access to available radiologists to balance the workloads. There will be also real-time access to the data, which means that unnecessary delays can be avoided and the administration can be reduced, or the operational efficiency can be improved. And there is also, of course, an online availability for multidisciplinary conferencing. Images can be shared through different locations within a hospital group when oncology patients need to be discussed between different disciplines. To give you an example of how the workflow goes with a cloud-based system, so images are being made by the radiographer, resident views them, attending radiologist, and then the clinician. So when these images are available, when using the cloud, there is seamless access from anywhere at any time. And there is access to the complete imaging sets, including the prior images and the relevant clinical information. There is also availability of the right set of diagnostic tools from any location. Appropriate viewers are available from any location, even for the referring clinician. It also means that there is streamlined image availability at the emergency department, and it also means that there is easy forwarding of images to other hospitals, which means that there will be timely preparation for emergencies. So the cloud does have a positive effect on the quality of care. For example, for traumatology, for example, for complex diseases like oncology, for obtaining second opinions, and also for teleradiology and telemedicine purposes. So these are all situations in which it's crucial to have all relevant medical data available. We are talking now about meaningful connectivity, which means that the cloud, and then also in meaningful connectivity, the cloud can play a role. It plays an important role in fostering better models for fluid exchange of images and medical information. The interoperability between all these systems, well, it can be guaranteed by using IHE profiles that are publicly available and that should be used to secure connections between the different systems like PACS, RIS, and the electronic patient records. For example, XDS is an example of such a profile that can be used for data and image exchange. By using the cloud, there's also a possibility to do intelligent pre- and post-processing of images, and this can be directly integrated in the clinical workflow. There's no separate workstation needed for doing this. The connectivity also becomes more meaningful when the information is used for data mining, for example, when data can be processed in a database, when these databases are accessible to for research. So the more information we can exchange, the better. So the strengths of clouding are summarized here. First of all, there are the savings, so the economics. We can make savings. Why? Because the IT has less need for investments in and investment of capital in the operating expenditure. There's a higher control of costs. So there will be a closer match between cash flow and the total system cost. And there are different subscription models between which the user can choose. And there will be no double examination costs. This can be avoided. There is also greater efficiency because there's more information available. The data can be retrieved rapidly, there's image sharing efficiently, there's a streamlined workflow, there's intelligent pre- and post-processing, and there's easy access to images at the point of care. And for the patient, there's an increased quality of care. The scan rate, for example, can be reduced, has been proven, by 10 to 15%. And there's a speedy transfer of data, which means that faster treatment decisions can be made. Let's think, for example, about the thrombectomy. There's also an unnecessary patient transport. The unnecessary patient transport can be avoided. So it can be decided if it's valuable to transport the patient or not. And so the treatment can, or the setting can be prepared before the patient arrives, which is also more efficiently. There are some concerns regarding the cloud services. First, one is the security. So still some people think, is there enough security regarding the access, or is the integrity of the data, can that be guaranteed? And can the data breaches, can those be prevented? There's also some concerns about the data governance. Where are the data located? Do we know that? Is there a sufficient protection of data, of patient privacy and confidentiality? And is it clear enough who owns the data and who controls them? And then there is also the concerns about the business environment. So are we sure that by using cloud systems there is enough interoperability between the systems? Can this be ensured also when we transfer to different locations? And is this reliable? Anyhow, the general perception is that the benefits here are outweighing the risks. Something I also wanted to mention is the new European legislation regarding patient data transmission. So this new directive will be effective in whole Europe from May 2018. And through this new legislation, there is an improved protection of patient data. I will explain this in the next slide. So what does the GDPR mean? What will change? So when in 2018, we will move to one single regulation for the European Union, which replaces a patchwork of all kinds of national laws. The GDPR, it addresses the protection of personal data and free flow within Europe, including healthcare data. It will ensure that personal data can only be gathered under strict conditions and for legitimate purposes. The customers, which are the data controllers and thus the hospitals or the medical practitioners, they must respect the rights of the data subject, which is the patient. And the cloud service provider or the data processor must protect information it handles and stores on behalf of the data controllers. So this is in some rough lines what the GDPR is about. What are the main features? There is a consent required from the patient for collection and processing of these data. The patient or the data subject does have the right to access these data, which also includes diagnosis, exam results, assessments by treating physicians, etc. The controller or the hospital should be able to provide remote access to this secured system. And each patient has the right to data portability, which means that the data that are being processed or collected in the hospital it should be possible to move them elsewhere. The GDPR also applies to organizations and cloud service providers located outside the EU. So even when, for example, American services are being provided, they should follow this legislation. What is on the political European digital agenda? Well, it wants to make the e-health successful, and therefore the European Union wants to incorporate the right of individuals to have their personal health information data safely stored within a healthcare system accessible online. So this means that the European politicians are supporting this kind of image sharing. They also say that by 2020, every citizen will have access to this data. So here we have a scheme of the strengths, weaknesses, opportunities, and threats. I will not go through all of them, but the main thing is the main strengths are important. There's less costs, there's cloud dynamics, we have easy management of IT, there's elasticity, we have, and we also have the GDPR, which means a guarantee for the patients. The threats, maybe there are still security about privacy, there can be loss of connectivity, the performance may be unpredictable, there might be hidden costs, there might be a lack of specific legislation or regulation. We still have to see about this. And there are several opportunities as well. We can access data everywhere, can be exchanged easily. The user can have access by using latest technology and applications. And there will be a progress in research, especially related to data mining. Patients' organizations, on their hand, are also in favor of this. They do have concerns about the guarantee of privacy, but they want facilitated access, and they also want the highest level of quality and safety. So they think we should improve, they also think we should improve interoperability and the data portability. So are we now at a paradigm shift? Well, at this moment, there are no technological barriers, but there are still some concerns, as I explained. And it also is true that some cloud projects have failed in the past, like in the United States. They wanted to launch the healthcare website in 2013, but there were, well, some problems quite soon, but these were caused by mismanagement and sloppy handling of contracts, etc. So yes, it could fail. Maybe we should see this as a transition period. Why is it going slower than we expected? Well, the current situation is that ICT is still keeping the brakes on. They are still slowly releasing because they're not sure how to handle this. Maybe this is because of the concerns they still have about security and reliability. Healthcare professionals, they are still a bit conservative, so they are hesitating. The politician, but in the main part, does want it, is in favor of it. In Europe, the politicians are in favor, and the public, they also want it. They want, we have this patient empowerment, which says clearly yes. So where are we going? We are going to a situation in which patients' data are and healthcare data are available independent of time and location. This transition is really driven by a market change, a technical change, by economics, and also by patients and politics. So we do see a progressive shift from a hospital-centric to a patient-centric hospital. So this is one of the last slides. We see here the hospital-centric model, which means that we have, all the information is stored in the hospital. We have data silos. The hospital keeps its secrets and its own techniques and developments. It's not shared. Every department is separate. But then we see the difference with the patient-centric model, which is all, let's say, centered around the patient. The patient can use different type of services like the mobile devices, Internet of Things, all the wearable devices. There's a possibility to use computer-aided diagnosis and treatment for each patient. There's a shift towards personalized care and genomics related to the genetic data of the patient. Patients are being involved. They can view their information. They can discuss their information, have questions about the reports they have access to. It's more open. We go to a more open system. So this is the last slide. So we are moving, that's how I like to call it, the liquid hospital, in which all the information can stream easily from one department to the other, and in which also the data streams are continuing outside the hospital to other locations and even can cross the borders. So this is the end of my talk, and maybe we can now shift to the discussion.
Okay, Erik, thank you very much for this really very clear and enlightening lecture. So please, if you have questions, type them in, and then we are ready to discuss it. We have We have quite a few minutes left to discuss. We had about 34 participants in this webinar. I think this is a very good number, and so now I hope for many questions. Erik, from my side, in one of your first slides, you mentioned trust. I think trust is very important. How is your feeling about trusting government and large organizations like Google or Microsoft, who already tried in the past to establish web-based health walls and other things? My feeling is that it would maybe be easier to run this kind of web services on a more regional level, where people know, for instance, their regional hospital and have trust in this institution. What is your feeling?
Yes, I do know that services like Amazon are already being provided for healthcare services, and especially in the United States, but they will also offer this in Europe. There's other companies that are setting up similar systems. For example, I'm thinking about Philips. But yes, I think when you look at it from the current perspective, then I think companies like Amazon, they might be able to offer a huge amount of services and at an incredibly low price because they are so big and they have a huge market. But from the reliability point of view, I think this is more difficult, especially when they provide services in separate countries, or for example, in Europe, when they have to follow the GDPR, then it will be more difficult for them. And the question is, how can we control this? How will we have precise information about how the security of the services and the location of the data, etc.? So from that point of view, I think local service providers might be more reliable, or maybe, to put it differently, might gain trust more easily from the local users. For example, what we see with the PACS on web, as I explained in Belgium, this system is already available and it's so popular that 80 to 90% of the hospitals in the north half of Belgium are using it. So there is confidence in this system, but it is also a local system.
How are you using this PACS on web? We are still waiting for questions to come in.
Yes, well,
the webinar.
Yeah, we are using it, and a lot of other hospitals are using it in different ways. First of all the patients do have access to their images. When they leave the hospital or the radiology department, they get a code, and when using the birthday and the code, they can just access the images and share them with somebody. They can forward this code and the birthday to somebody else. For example, I often get requests from people I know, please have a look at the images that were made at that hospital. Can you have a look at them and tell me your opinion? So that's one possibility. And another way we are using it is, for example, when patients come from another hospital, we can simply download the images into our PACS by using the PACS on web services. Or when patients go to a university hospital, that hospital can also use the same system to download the images. So yes, it's very flexible.
So this eliminates redundant examinations also. Do you send all your images from your hospital and from other hospitals in the northern part of Belgium to this Webpack?
Yes, this is not the only one. There's several players in the market, but this is one of the biggest. And yes, all the hospitals that are customers do send the images and even the reports in some cases. Well, the reports are being sent and they are accessible in most cases, not for patients, but only for referring doctors. But this is there is some variation. Some hospitals also provide the reports for the patients. But yes, all the images are being sent to that server. It's not a parallel PACS, so the history is not as big as we do have it in our own system. It's only the latest examinations or a limited historic. Not all the priors are available, but just a limited amount.
Okay, are there any questions from the auditorium? I'm still waiting for some input here. Did many participants? Did Erik answer all your questions? Erik?
Yes?
You wanted to say something?
No. I was wondering if they are still there, but I guess so. Yes, they are online. So yes, please go ahead and ask any question.
Okay. Do you use any thing like post-processing on web platforms? Do you have any experience with that?
Yes. Just to give you a simple example, we recently installed a software called Bone Expert, and we use it to read bone ages. So the images are being sent automatically to the outside located server, and within 30 seconds we do get a post-processed images indicating the age of the patient.
We also use it, yes.
Yes. So that's one example.
Great service, yes. Okay. Any questions? This doesn't seem to be the case.
No. Well, might be I have been very clear or something.
and very complete also. So I think this is a very important topic, and we will have to discuss it again in the future. Things are moving there. And so, Erik, once again, thank you very, very much for this lecture, and thank all the participants in the auditorium. Oh, there's one question coming in.
Okay.
Patient data security. You touched it in your lecture, but maybe you should tell us a little more.
Yes, the patient data security, of course, it should be guaranteed, and there is a European legislation or a directive that has to be followed. So the companies have to adapt to that type of legislation, which is ongoing. At this moment, it's not 100% safe yet, but this from May 2018, there will be more strict regulations that will protect the data more securely. So yes, it's an ongoing process, but the legislation has been voted, so there's no return. Are you still there? Yes? Okay.
I'm still here.
Yes, what I also wanted to... Yes, go ahead.
We still have 34 participants, but not many questions coming in. And Amir, who asked the question, is satisfied with your answer.
Yeah. I also want to say that this presentation will be available on the EuSoMII website for the members. So I would also like to encourage all the attendees to become a member. It's not expensive. And our society, the European Society of Medical Imaging Informatics, does give you the possibility to stay informed about all new kinds of developments in this field. I think our society, of which I'm the vice president, as you know, will offer the public or the radiologists to engage more intensively with these new developments, which I think is quite essential and has been maybe has been neglected a bit in the past. So we should improve this. I think we should improve our involvement in these new developments. So please feel free to go and have a look at the website. And if you're interested, don't hesitate to become a member.
Okay. Okay, so I think that's it for today. Erik, once again, thank you very much, and thanks to all the people in the auditorium and for the question and for your attention. And please go to the EuSoMII website and check it, and it's very easy to become a member, and it's not expensive, and you get a lot of information. So good evening to everybody.
Okay, Elmar, thank you very much for having moderated this session. And thank you, everybody, to have attended this session.